Ladies and gentlemen, welcome to CemeCon. Great that you're with us. I would like to talk to you today about market opportunities for your products, cutting tools with HiPIMS and diamond coatings. You will probably ask yourself the same questions as what we do. Where are the future markets? How can we overcome the current situation? Where is the thing heading for? What is the direction to go for? Well, traveling, personal exchange, meeting people, discussing with people is always great, always gives fascinating insights, fascinating impulses. Traveling is not so easy in the moment, and your health, your safety is key to us. Therefore, it's really great that we can do it, that we can join now by video. And I would like to thank all the people who contributed to making this video happen. My name is Christoph Schiffers, and I would like to take you now on a small journey through how we see the development of the coating world for cutting tools and where we see market opportunities for your product cutting tools together with cutting tool coatings. Already in 2019, we saw a development in the market coming from the car industry. The car industry is a quite dominating market for cutting tools, and we all saw the first signs of the change from the conventional combustion engine to an e-car, a hybrid car, or whatever variety will in the final end come out of this. You produce precision cutting tools. We coat these objects and only cutting tools. That's how we would like to differentiate ourselves from other vendors by focusing on your industry. So the impact, which is on the cutting tool market, is a quite important one to us. And well, now we have the situation around COVID-19. Only because of a safe distance to all the people helping here, I can go without a mask. COVID is an issue, yes, of course, but the trend on the cutting tool market was there already in 2019. COVID just makes it quicker, accelerates the trend. So we all need to look for future business opportunities. We would like to look for future markets. Tony Leindecker founded CemeCon about 35 years ago with an, at this time, very innovative idea: sputtering titanium aluminum nitride on cutting tools. At this time, brand new, a real technology leap forward. Today, about 80% of all tool coatings based on titanium aluminum nitride. I would like to talk to you about diamond and HiPIMS, the logical development or following technology out of sputtering for cutting tools, for cutting tool coatings, and what is the market impact for your products out of these technologies. Where are future markets? And of course, there is definitely something to produce for cutting tools and for us as a tool coater. In developed markets, like here in Central Europe or wherever, the average age of the population is steadily increasing. And of course, more people will need to go for a hip implant, a knee joint, or whatever to maintain their mobility. And of course, society in developed countries will donate the necessary money, the necessary funding into healthcare to give also people needing such implants a good life. The production of these implants today is mainly out of chromium cobalt, a very nice market for cutting tools because chromium cobalt is very hard to machine. Here we need a dense coating, being good for a challenging material like chromium cobalt. And another thing is quite special in this market. We need a perfectly machined object because these implants are going into the human body, and every damage to the surface is a potential place where bacteria can nest, what of course is an absolute no-go and must be avoided. So smooth HiPIMS coatings generating a perfect surface are the first choice for such a product in the medical industry. Another example from the medical sector is making dental implants from zirconium oxide, milling blanks from zirconium oxide with the individual shape and generate the implant online in a CAD/CAM system. A fully new way of doing this. The good thing for you as a cutting tool maker, you can use your tool making knowledge together with our diamond coatings for a new market, which is not subjected to the typical ups and downs in metal cutting industry and in engineering. Well, we all have learned in the last half year how essential communication to all of us is. We all have sit hours and days in front of Teams, Zooms, and whatever video system. And 5G technology, the next thing in communication, will come. And we all will invest in this to be prepared for a similar situation like what we face in the moment. A telephone, a tablet is today a metal frame, aluminum, some are made out of stainless steel or titanium, and a lot of milling tools are used to shape these frames and to generate a perfect surface. Here it's about milling tools, micro milling tools. For micros, you must have a droplet-free surface. Droplet-free is HiPIMS, so that's a quite big benefit for micro tools. And the other thing, a micro has a very sharp geometry, so you must find a way to bring down the stress in the coating so that you have fully coated cutting edges. Communication and medical industry are definitely rather interesting markets where we can immediately generate new business with HiPIMS coatings. And you might now ask, what is so special about this technology? Why is it so different? And when you just take a look into a HiPIMS machine, the first thing what you notice is this very bright, very white color of the cathodes, already indicating just from the color impression that there is by far more energy in the plasma than what you used to know from any other process. And that's a basic idea between HiPIMS, not putting the power constantly on the cathodes, but putting the power in short power pulses, high impulse magnetron sputtering on the cathode. In the pulse, enormous amounts of energy, giving an almost 100% plasma ionization, but it's still sputtering. So you keep a droplet-free coating and you add energy to the process. Showing this on two quite visible examples. Here I prepared on the left-hand side a micro drill, diameter 0.2 millimeter. It's already an art grinding such a tool, quite challenging in coating. And the good thing in this pulse technology HiPIMS is that you have more parameters to tailor the energy for a certain object. You have not just the pulse height, you have also the pulse length and the relation between on and off time. So you can tailor the energy precisely to an object like here, this very small drill with very sharp edges. And what you see here in the scanning electron microscope image, perfectly coated surface, perfectly coated primary and secondary cutting edge. The other example on the right-hand side is even more striking. It shows a router tool for shaping printed circuit boards, for example, for your telephone or for such a presenter, the electronics. A very sharp geometry, very much looking like a wood machining tool. Here, it's clearly visible from the geometry that the coating must be very tough, very dense, and you must find a way to bring down intrinsic stress to cover such a sharp geometry homogeneously. And stress management, that's a fully new thing, what you can do by tailoring the HiPIMS pulses in the right way. Another very good example from a fully different type of tool, Indexable inserts, is Ferrocon Quattro, the first product with 12 micron PVD coating, a so far fully impossible coating thickness. And here you see through all the 12 micron an undisturbed morphology, no voids, not in the coating, not on top of the coating, very small grain sizes, giving a very good toughness. And just being capable of having 12 micron on the carbide substrate is a very nice illustration that obviously stress management in HiPIMS is working on commercial cutting tools. You might now ask, why is HiPIMS so different from other technologies, from other traditional coating technologies? And the point is that in the pulse, where the plasma is generated from the cathodes, we have at the same time high voltage and high amperage, driving a lot of energy into the plasma. And this makes it so different from other things where you have either high voltage or high amperage. Well, we talked about stress management. How can we come a bit closer into this quite difficult technology? Well, from your tool point of view, you grind a nice surface, you prepare your cutting edge, you do a honing process, and then you give it to a coater, and when you get it back, you see this. Spallation of the coating, peeling, or the cutting edge is no longer coated fully. You see at some spots even the carbide. Obviously, the intrinsic stresses in the coating were not fitting to the geometry. Well, how to avoid this? And the key technology step forward in HiPIMS is that we as CemeCon were not just looking into putting pulses on the cathode, but analyzing the process and synchronizing the pulses on the cathodes with what's going on the bias table. On the bias is your tool placed and is receiving the material from the cathodes. And from the cathode is coming during the pulse the metal from the target. That's of course what we want for making the coating. But on the other hand, there are in the plasma, just from the nature of the process, some unwanted additional species in the plasma. These ones should not go into the coating grid because they distort the grid and they make the stress. And the thing in HiPIMS synchronization for selective ion biasing is attracting the metal coming from the target, that's what we want, and suppressing the unwanted parts. And this process knowledge is now incorporated in our CC800 HiPIMS and is the key to bringing down intrinsic stresses in coating. For your coating products, and when you incorporate this machine in your production, you can apply it in-house on your products. The benefit for you is you can increase coating thickness a lot. In traditional technologies, your limit on a industrially produced insert will be anywhere around 4, maximum 5 micron. Now, with stress management, we can do it on an industrial scale with 12 micron with Ferrocon Quattro, day after day in standard production. This is a real step forward and makes HiPIMS and the CC800 HiPIMS very different from a CVD process where you can apply a thick coating, but always with tensile stress. Tensile stress is okay for turning, but is a no-go for interrupted cutting like milling. And the market is clearly going for heavy-duty machining in the milling direction. Yeah, the good thing in HiPIMS is control about the process. Intrinsic stresses are not bad by its very nature. When you go into a church, a church is only supported, or the roof of a church, by stresses on the cornerstone, or the bridge you are driving over is only capable to bear vertical loads by highly stressed steel wires in the concrete. There are applications in the cutting tool market where some intrinsic stress is helpful. Here, a typical example from the mold and die market, a ball nose end mill where we need all abrasion resistance, all hardness to be able to machine, for example, 65 Rockwell hard material. So here the point is we can actively influence with the CC800 HiPIMS intrinsic stresses if we want them, and we can influence them in the right way and the right value. And that's one of the key points of the HiPIMS technology and the CC800 HiPIMS. You can do the full range of products with very different properties and very different requirements. Here from a tap drill, where everything is about reducing friction, droplet-free coatings, having a low torque while you are doing tapping. In the middle you see a micro cutter, droplet-free, low stress to be able to have a thin coating around a very sharp geometry. Or on the right hand side you see milling cutters where you would like to have a bit more thickness, but you must have toughness in the coating to be able to fulfill interrupted cutting on the best possible level. Well, the same also for indexable inserts, a completely different type of tools. Also here quite a variety. On the one side we see an insert with an aluminum geometry, quite sharp geometry. Here also a good example for the flexibility of the CC800 HiPIMS. The coating here is titanium diboride, a material which you can easily sputter, not with any other technology, and it avoids the adhesion or the sticking of aluminum to carbide. A good example to show the flexibility and the versatility of the CC800 HiPIMS. You can deposit almost any material on any substrate, whether it's carbide, whether it's CBN, whether it's ceramic. On the other hand, you can do with the same machine, with a different process data, a very thick coating like Ferrocon Quattro on a heavy-duty milling insert like what you see, this hexagonal insert in the middle. On the right-hand side, grooving a quite interesting market where not so many producers are in, so a more open market field. You always have sharp corner edges. Sharp corner edges here, the big benefit is in HiPIMS that you have a dense film with low stress, and you can easily cover these crucial corner points quite well, and you have an undisturbed cutting edge. And of course, grooving is always interrupted cutting. Low compressive stress from the HiPIMS process and the CC800 HiPIMS is very beneficial to such a grooving tool. Yeah, starting from the basic screen of the machine where you see the selected process and the operation status for the typical operator, a development engineer can go a level deeper into the process itself. Here you can see all the data, all the process set up completely, and by pressing on any of these command lines you get full access to all data, whether it's power on the cathode or synchronization data down on the table, and you can actively change them, modify them according to your coating design, according to your product, so you can dedicate your own proprietary coating. So the decision for a certain coating technology and for a machine like the CC800 HiPIMS was never so easy as today. Here in this table I try to summarize some key points for your decision. The good thing in HiPIMS is we are 100% droplet free. That's the reason why this process is different from all others. Very suitable for microtools, a booming market. We can do very thick coatings with low compressive stresses. That's a big difference from CVD. Also in CVD you can do a thick coatings, but always with tensile stresses, which is a clear no-go for interrupted cutting like milling. That you can do in HiPIMS. And on the other hand, a HiPIMS machine is very easy to operate. You have no precursor gases. You can simply integrate it in your production. So, and the big point in HiPIMS is prime quality, ease of operation, dense coating, low intrinsic stress in one technology, in one unit, the CC800 HiPIMS, for all tools, whether it's round shank tools, whether it's inserts, from 1 micron to 12 micron in one unit. And I think this is the point why we see a very strong market reception of the CC800 HiPIMS, and we clearly believe that this is the way for the future to go in cutting tool coatings. There's a number of applications in the cutting tool market where you need diamond, the hardest material on earth. Your cutting tool, your geometry, your edge honing, together with this super hard material, here coming from the CC800 diamond, brings us into markets which have promising cutting tool business for the future. And the interesting thing here is also here is a number of markets outside of traditional engineering. And I would like to show you some of these applications where we all are sure that we will have some beneficial business in the upcoming years. The classical application for diamond coated tools is graphite machining, typically for electrodes for EDM machining. Here you see a mold. Such a mold is being used for pressing glass, for cell phones, or for tablet computers. And here we are again in communication, an industry, a consumer industry, which is definitely booming, and especially telephones for schools or other applications are a clear trend. And now you can use your graphite tools together with our diamond coating for such a market like communication. The other pretty new application is the production of dental implants. Traditionally, they would have been done in a laboratory, offline from your dentist. Today, there are small cut-cum systems on the market where a model of your teeth is directly scanned, and with milling cutters is a copy made into zirconium oxide blanks to generate your implant while you are visiting your dentist. The good thing here for you as a cutting tool manufacturer is, from the tool point of view, from the geometry, is such a tool very similar to a graphite cutter. It's a typical ball nose geometry, together with our engineered coatings, engineered over 20 years of experience. You can provide cutting tools with your existing equipment into dental and the healthcare market, which is by far more stable than every engineering application. Well, you like challenges, we do. One of the most interesting challenges in the cutting tool world is machining of cemented carbide in the hard state. You might know this from your customers, or when you produce cutting tools and wear parts, you will have a number of applications in your workshop where you have to machine, to shape sintered parts, what you will typically do today with EDM machining or with grinding. Directly machining with a milling cutter is much, much faster and generates enormous savings for the end user, which of course the end user is willing to pay you for the cutting tools. This new product, CCDR Carbide Speed, is the essence of 20 years of CemeCon diamond technology incorporated into the CC800 diamond. Here we need all possible adhesion of the diamond on the substrate, so we re-engineered the chemical preparation of the carbide, and also the process in the coater itself is made to do this super challenging application to the best possible way. The enormous potential of this application machining sintered carbide is shown here in these two graphs. In the upper one, you see the conventional way, preparation of powder, pressing, and then you would apply steps like EDM machining, like grinding for shaping your product. When you can cut this down by directly milling a sintered part into shape, then you have dramatic savings in the process change. And this, of course, is a big advantage for the end user and an enormous chance for you as a cutting tool producer to supply such tools. Yeah, ladies and gentlemen, I hope I could show you a little bit how we see the future and the direction in PVD HiPIMS and in CVD diamond, where we do see prospering markets, and they are there. And well, it would be great to have you here with us to show it to you with your tools personally, which of course is in the moment not so easy. Therefore, we are offering you an online live badge for you, for your cutting tools and your questions. So please feel free to visit our webpage and book your personal online live badge. Thank you very much for your time and for being with us. And the most important thing, stay safe and healthy. Thank you.